Hi everyone, and welcome to this tutorial on naive forecasting in SAS EG, and let's get started. So first of all, you need to create a program. Let's do this. And you need to create a directory that SAS calls library. To do this, you have to write libname and give it a name. Because this is a BSTA477 class, we're going to write BSTA477. And now you also need to indicate the path where SAS needs to store files and also access files in its own format. So this is where I'm storing these files, and this is what I'm going to indicate. That's it. So libname, the name of that library, and the path, and a semicolon. And remember that the path has to be in double quotation marks. So let's run. And you can also check if you didn't make any errors. You will see this green announcement or note that libref BSTA477 was successfully assigned, blah blah blah. So now we have this library, and you can actually check it out here. So pretty much what you will typically see will be servers. You can open them, local libraries, and then you will see BSTA477. And if you have any files in or data sets in SAS format, you will see them here. And you can see that I also have in the same folder, DMB or datasets, I also have some CSV files, and also some files in R format, but SAS doesn't see them. What it means is, it means that actually we have to import the data. So what we're going to do, we're going to run a naive forecast on this track dataset. And let me just open it, and I will show you that it only has two columns, and one of them is a date. It's collected on a monthly basis from 1991 to 2004, and also ridership, right? So ridership is in thousands, and it's how many riders used Amtrak on a monthly basis. So that's all it has, and that's all we need actually for time series. So let's go here and let's import this file to transform it into SAS format that SAS will be able to understand. To do that, you go to File and Import Data. Now we have to find it. It's called Amtrak Data. And here you have to check out for this one. That is why actually it's very important to assign the library before you actually do any operations on that. So this library work is temporary library, and if you close or when you close your SAS session, your file will be erased. I mean, the file in SAS format. It won't be erased in the CSV format, but it will be erased in SAS format. And if you don't care about it, if you just need a temporary file, don't bother about it. If you still want to save it forever and ever, you go to Browse, and then you have to click on Servers, Local, and then click on this library and give it some name. For example, we can call it Amtrak Data _Amtrak _data. And now we can continue, and that's what we are going to have. It's a comma delimited file, right? Because it's CSV. Also, it asks you a few things. File contains field names on record number 1, which is true. So data record started at record number 2. Sometimes you may have sets, data sets, where you will have, let's say, a header that occupies 3 rows. So this is really useful, for you to know. And sometimes you can also have fixed columns. We don't. So that's why we are going to keep everything what SAS identified for us. So the next, that's pretty much all. It tells us that this is our month in a specific format, and this is our ridership, and next and finish. So we will have our file here, and actually if we go to this folder, we can see right now that we also created a SAS file. It says SAS dataset, right? Amtrak data. So that's how it works. Now we have this data, but now we because we want to do time series analysis, we are going to go to Analyze and Time Series and Prepare Time Series Data. This is actually where it all starts. So we're going to start, let's check, our data starts in January, so we will have to create a new variable. It's called month, which is perfect. and intervals is set to monthly. You can also create a new one if you want to. I will show you. Sometimes you may not have it, so if you don't, you can just go to new time ID, put it here, and what you can do is you can actually say starting date and interval. So interval is monthly, and starting date you will have to choose it. So our data starts in 1991. That's what we need to find, January, and it's always going to be the first day of the month. So this is our time series, time or date, right? This is our date that we have available, and we can give it a name. We can say date, for example. And the time series variables will be ridership. That's all. We only have two. And we can just click run. Let me see. Yes, perfect. So ridership, replace existing variable ridership. That's exactly what we need to choose. Run. So right now you have to know, right now what we created is we with you created just a temporary data set. If you go to modify task, you're going to see in the results that the file has a crazy name. It's local work TSD time series whatever, you know, it's really difficult to read. So if you want to save it forever, again, you will have to click on browse, and you will have to go through all these servers, local, the library, and you can say track data time. So now we will know that this is time series, so you could say TS. Now we'll run again, and we'll click yes. So right now we can actually go back to this folder, and you can see that we have untracked data time. So now we just created a new file, but this is a time series file. So the first thing, let's check it out, let's check out what we have, right? And we'll go for line plot wizard just to analyze the data, because it makes no sense to run a forecast if you have no idea what is going on. So SAS sometimes confuses these things, and it suggests that date should be the Y variable and ridership should be the X, but it's actually the reverse, because we believe that time has an impact on ridership, right? So horizontal is date, vertical is ridership, and we can just say finish, and now we will have our graph, and that's what we see. So first of all, we may definitely observe a trend, right? We can see that we have rides first that go down, and after that that they increase, right? Also, we can see some seasonality, because you can see sometimes there are spikes in the data, right? So that tells you that we do not have a very simple, stationary data. And that means that maybe naive forecast won't be really appropriate, but we will still use it as a benchmark model. And there are a lot of other models that we can use as benchmark models, but we're going to start with this one. And let's go, let's go straight ahead and let's do this. So what is cool? I'm gonna write a comment, naive forecasting. And the first model, we're going to use simple naive. This is the first model we're using. So before we even do anything about this, we actually will need to do a few things. So we need to always split the data into two parts, right? One will be, or sometimes three, but right now we're just splitting it into two. And let me just go here. So this is our output data. We will need to split it into two parts, because we need our data for training the model, but also we need to validate that model, right? We need to see whether our model is good or not. So our goal is to actually preserve 3 years of data. We have March of 4, and we will start with March. No, it has to be April, right? From April to March. So we will start with April 2001, and that's going to be our validation set that we will use to validate, to see if our forecast is actually working on new data. And the rest, what we have before that, we're going to use to identify, to train the model. That's all. So to do that, you go to filter and sort. And if you look at this area here, this is actually the area where you can, where you're creating your new data set, you know, that's all. So that's why if you want to have these two variables, you have to just move them to the right, and that's how you're going to keep them. Now we need to filter our set, and we'll filter them by date because that's how we're going to split it. And let's say that we want less than or equal to, and let's go for that date that we decided on, and that was April 2001, right? So this is our training data set, and we're going to call it again BST477. You can just click browse to create that set in that library. So we'll call Amtrak data train. So this is our train. Let's call it TR to make it shorter. Amtrak data TR. Okay, and so we have all the data including April 01. Oh, that was my mistake, sorry. So let's go to modify task. That's fine, you know, it's okay to make mistakes. Let's just actually let's not change this one, but let's just change so cancel. Let's change it here and let's say less than, and that's it. Now we'll have everything modified properly. Yes, so until March, and then we will start the next year beginning in April. So this is the data that we have for our train, and now we have to go back to the original data, and we will have to take the rest of what we have, right? And we will have to create the validation set, and we're going to be using them on and off, you know, when we are running our forecasts. So date and ridership will be in the new data set as well. We'll go to filter, and we'll say that we want to filter by date, and now we want actually to be we want it to be greater than or equal to, and now we'll finally use that April 2001 to create it. Okay, and let's go to the results, and again it will be BSTA 477, and be careful because if you make if you mistype anything here, SAS is going to give you an error. So just, you know, either go to change or browse, or, you know, type it, but make sure that you do it properly. So BST477, and we'll say Amtrak data V, so it will be validation, and that's it. So we have 36 periods that are left, which is exactly 3 years. 12 by 3 is 36, and that's exactly what we need. We're going to be using this to see how well our model is able to forecast. So now we are ready. We are ready to start. And let's start with the simple naive. So what a simple naive forecast does, it pretty much does a very, very simple thing. It takes your point, let's say January 91, and it forecasts February. So it thinks that the next period is forecasted by its previous period. That's all. And in SAS we have a function that's called lag, and that's what we're going to use. So let's start, and let's create a new data set. Okay, so data, let's say naive. This is what we are creating. In SAS, that's how it works. So at first you begin with what you are creating. So let me say here, creating a new data set. Now we need to say what set we are calling. So it will be BST477 dot, and if you remember, by the way, I wanted to show you, right? So we just created these two sets. It's Amtrak data TR. We should also have it here. We can click refresh, and you can also see that we created these sets. They're here. So if you forgot, just go there. You can click rename, Ctrl+C, and that will give you the correct name of your set. SAS is case insensitive, so don't worry if you type it you know, with all caps or not. No, doesn't matter. This is using the existing set or data set. Now what we're going to do, we are going to create a variable called forecast, and it will equal to a leg of, let me just open this set here, data set, a leg of ridership, and that's what we are doing. So leg, ridership, and again it doesn't matter if I write it with a capital or not, and at the end we will say run, and that's it. So let's just select this and let's run and let's see what we have. So you can see that the first forecast is absent, but then we have the forecast for February, and this forecast actually equals the forecast for January. And that's it, you know, so that is our naive forecast. Now what we need, we actually need to take this forecast, the last one, and we will need to calculate errors. Not errors, sorry, we will need to use this exact number that we have for March 2001, our forecast, and we will use it to forecast everything in these 3 years. So it will actually be just the same number, but that's all we can do, you know. So let's do this. Let's take that number and let's run the forecast. So we are going to use our validation set, and will be data naive, let's say valid, and again set that we are using will be BSTA 477 and track underscore data v, right? And again we'll have a variable called forecast, but we will not be using a leg, okay? So what we'll have to do actually, we will have to use the last value that was here, right, that existed here. And to do this, we will actually need to create a separate set. We will only have one value. We will only have this one. We will come back to this later. For now, let me just enclose it into, sorry, in quotation marks, no quotation marks, into the comment boundaries. And let's create first the naive set, data, and we'll call it x, for example, and then we'll have set, it will be called, yes, naive, because that's exactly what we need, and we'll say where, and forecast, no, actually not forecast, let's say where date, right? Where date equals to mar01d, and run. We can see if it works or not. It didn't work, so it will be 0 first. Okay. Okay, it worked. So now we have this set that only contains one thing, and we are going to use this forecast from this set that has only this forecast. So we can say where date equals, and we can also use here keep forecast. That's all we need to keep. Keep equals forecast. We will only keep one variable here. Perfect, so that's all we need, and that's what we are gonna have. So now we are ready to continue. So here, let me just leave a comment, creating a set, data set, with only one value. Okay, so now we are going to add the value from the previous data set to the validation one. Okay, so we have now data, naive, set, we have it all here. So what we are going to do is this: if n equals 1, then and we'll call that set is called x. Run. If n underscore equals 1, run. Okay, then set x. Okay, sorry guys, I don't use this one very often, so that's why we have this delay, but it's okay. So it shows you that actually it's an iterative you know, an iterative thing, right? Sometimes you make mistakes, it's okay to change them, and that's how you arrive at this. So as you can see, we have the date, we have ridership, and we also have our forecast, which is actually perfect. Now all we have to do is to calculate errors, because we have all of our forecasts. And actually what you could have done, you could have just gone here, you know, we have this naive validation set, we also have our naive data, which is the training set, right, with the forecast, and you could just click on export, and you could say export naive, and you could find where you would like to save it, and then you can just choose here CSV or XLSX and save it, and then calculate all of this in Excel. You know, you could calculate the residuals and all the rest in Excel, which is also possible, and I mean, why not, right? But we are going to do it the long way, and we are going to do it exactly here, exactly in SAS. So for that, we actually going to calculate many error terms. And let me just specify what we are going to do. Let me just go this way, and let me remind you what error terms we have. So error terms that we are going to calculate, and we're going to start with these ones. So we have a few. We have MED, mean absolute error. We have MSC, mean squared error, RMSC, root mean squared error, and also we have MAPE. This is mean absolute percent error and mean percent error. So that's what we have, and that's what we're going to calculate. You don't need, so why we need this? You actually need to calculate these errors to see by how far you're deviating from the actual data. And of course, the higher these numbers are, the greater they are, the worse your forecast is. But also what is cool is that you use this for a few things. You use this, first of all, to identify how good your model is by itself, right? You want to compare the training and the validation sets, and you want to see if your training data sets error are very different from the validation data sets error. And if they are, it's a very bad model, because it overfits the data, or at least it doesn't forecast really accurately, you know? So the math formula is you need to find the mean of absolute actual minus forecast values. So I will just write it as sum, and then we need to indicate that this is the absolute value we are looking for, so actual minus forecast, and sorry, and we need to divide it all by the number of observations. So also we have our MSC, and again sum, and now we only need the actual minus forecast. This is not the absolute value, so this is just the mean squared error. The only difference that will be there is that we need actually to take a square of the sums, okay? So you need to take the square of this difference. So then RMSC, it will be, 1 second, so it will be just the square root of MSC. We're not going to calculate anything here except for this. Then we have also MAPE, which is 100% multiplied by the sum of, because this is absolute error, so definitely you have to use this. It will be actual minus forecast. But what is also cool, you actually have to divide this by the actual value, because you want to see how much of an error you have out of the original observations. You know, to make it a little bit more correct, maybe let me just add another bracket here, and you divide it all by n, because you need the mean, right? So actual minus forecast out of actual, and this is our sum. Yes, perfect. And then you have to actually you give it in percentage, as you could have guessed it. So the same will be for MPE, mean percent error. The only thing is that now these brackets, straight ones, are going to be gone. You don't need them. So it will be sum of actual minus forecast over actual, and we'll need to show that we are not actually summing them until we perform this operation, over n. Okay, so this is the way it's done. Okay, and now that's what we are going to do. We are going to calculate these errors. So let's go for this, and let's see how we can do this. What we actually need is we need to create a few things, right? So let's start with the number of errors for the train data. And here we have this set that is called simply naive, and this is the set that contains our forecasts for the training data, right? So let's start with this, and let's create a new one. So data BST 477, we're going to create a permanent set, and we'll say number of errors train, right? Okay, so that's what we're going to do. And now let's go also for the next one. Let's create a few things. So we'll use set naive, and you can see actually what we need here, right? We need the absolute difference between actual forecast a few times, right? That's what we are gonna do, and that's what we are going to need. So we'll say abs, for example, okay? And it will be ridership minus forecast. But because we need them to be absolute, we'll have a function that is called abs. Also, what we need, we will need to add a little bit more. Just give me 1 second, guys. Yeah, we will need to create the next one. We will need to create just let's say diff, okay, and it will be a difference between the actual forecast and the forecast, okay. So it will be, and you can see that we need it here, and also we will create a squared diff just, you know, once we're ready. So actual ridership minus forecast, that's our diff, right? We don't need any absolute value. Also, what we need to do, we need to create diff2, like diff squared, right? And it will be diff to the power of 2. You need the correct symbol to do that. And we will also need to divide the diff, right, by the actual. And you will also need to divide the abs by the actual. So that's what we are going to do, and let's say division equals, we will have first abs for the map, right? Abs over ridership. And we'll also create, let's call it maybe div. And we'll also have division, maybe let's call it div abs, and this one will be just regular reg, so that we could know what we are talking about, right? So it will be diff over ridership, and it seems to me that that's exactly all we need. And now we are ready. Now we can say run, and let's see what we have. Because this is something like our preparation, you know, our preparation to do more. Okay, let's see, there was an error. Syntax error. Oh yeah, sorry guys, this is in R. That's how you do it in R, or in Excel. In SAS, that's how you do it. Okay, run. Okay, so now we have our forecast, and we have our absolute values, our diff, our diff2, and the division, regular, not regular. So that's all that we have. And actually, I will tell you that you do not have to create a separate set for this. What you could have done, you could have just taken all this, and you could have used it when you were creating your forecast. So what is cool about SAS is that when you're running your program, it reads it step by step. You know, it doesn't it kind of, you know, does the first line and the second line, the third line, and so on. Unless of course there are some specific conditions when it has to go some other way, but typically if you place them in the right way, you know, at first you will create your forecast so that people could actually, so that SAS could actually read it, then it will be able to calculate all of this for you. So let me just show it to you. Okay, so we actually have the same, but now we also have the forecast here, and we have all the rest that we need here as well, which is perfect, right? We do not need to worry about anything. And now we can do the same for our validation set. So this saves us one step. So let's do this. Let's now do this for naive. Oh, sorry. Run selection. Yes. Let's run just selection. So again, you can see that we created the variable. We didn't say that we were creating the variable called forecast, but because we only had one, it used that variable, the only one available. And now, because we mentioned that variable, SAS was able to calculate things for us. So now that saved us one step, and now we can continue. So what we are going to do now, we are going to just focus on calculations or the rest of the things that we need. But before that, let me just copy, you know, because I'm really bad at this, and let me just copy the names, okay, so that I could do it in a proper way. So now, guys, you need to remember what it is we are doing. And what we are doing is this. We are going to calculate the errors, and for that we are going to use pretty much means everywhere, right? So the MAD means a mean of the sums of all of these things, right? And that's how we are going to start doing it. So let's start. We have proc means, and we could actually calculate the sum of all of these things, and that's what we're going to do. So let's say proc means. Proc means is a call. You also have proc summary, but we're going to use proc means to calculate sums and means as well. So proc means data equals, and we're going to start with our set that we had here, and that is called naive. Okay, so proc means data naive, and we can also here we don't need to indicate any no, we don't need any equal mark. So we have proc means data naive. Now vars, and what we are going to use here is these variables over there. So we're going to calculate the sum of the absolute residuals right here for the MAD. So we'll say abs. We'll also need to create a sum of the squared residuals, which we called diff2. We'll also need to calculate the sum of these values, right? So we'll need to calculate them. So that's what we called div abs. And we also need the regular, which we'll call div reg. That's all that we need here. Now we need to indicate that we would like to create a separate file. It's called, you need to say output, and then out equals, and we can call it, for example, VST, we don't need to create a permanent file actually, so let's just call it output out, and let's say some naive train, and we also need to say that we are only interested in the sum, and we'll say auto name, so that actually we have a suffix that is added to the new names of these apps, div, and so on. Okay, and now we'll have run. You will see actually how cool this thing is, because this thing will let us use all of it. 1 second. Perfect. So here we have our n, and our n is 122, which is true because we do not have one value is missing, right? So we have also standard deviation, minimum, maximum, mean, which we don't need, right? We actually needed just the sum. And yes, so that's all we have. But let me just see what happened here. Sum equals, why did we have the mean? Why did we not have the sum? Okay, yes, now I see. Okay, so let me just say yes. I remember now. So, sorry. What happened here? Run selection. Oh, okay, yeah. So this table doesn't tell you what you want to see because it runs by default and it gives you the output. Okay. What you could do, you could actually even say no print, and you wouldn't even see that output. You would only see this one, and that's exactly what we need. So we have this frequency 123, but that's not gonna be the exact number that we are going to use to calculate errors, because the first row, if you remember, here for our forecast, we can find it in the work library now because this is temporary data set. Let me just find it. Yes, it's called naive, right? So you can see that the first row is missing because to forecast our January, we would need to have the data from December 1990, right? So that's why. Now this is all we have, and we are going to use this really cool thing again. If you only have a data set with only one row, you can use the same function or the same command that we used before here when we were creating this set with only one row and actually only one variable, and we use this command if underscore n underscore equals 1, then set blah blah, and that's what we're going to do. So let's go, and remember that here, let me just say that we are calculating train errors. We are going to go for this one, and we are going to create a set that will add actually all these sums, and also we will have the frequency, and we will have everything calculated and will be located in the same set. Okay, so let's go, and remember that here now we're interested in this set. We will be calling it later. So data, and we'll say naive forecast, and also errors or as. Maybe errors would be better. And now we'll also use set, and the set will be not this one yet, but our naive set that already contains all the information that we need. So it will be set naive. Also, we are going to use this condition, right? If underscore n underscore equals 1, and then set some naive tr, and that's gonna add all that information. So we're going to be adding more stuff on the go, and let me show you what we have for now. So we have now a lot of stuff. We have our original data, and also all those variables we created, and type and frequency, and the sum, absolute sum, and you can see that it's the same value, right? So it was just replicated multiple times for us to have a look at all of these values. And we are honestly not really interested in these values as much. What we're interested in actual errors, right? And that's what we are going to be doing now. Now we also need to add, we have this frequency, and the frequency is right for the whole number of rows, right? Rows. But it's not correct for the number of n to be used in the formula, right? Because now we don't have 123 rows, we actually only have 122 rows, and we need to take that into account. So what we're going to do, we are going to actually create a new variable. We'll call it n, and it will be equal to frac. We don't actually, sorry, let me just check how frac is spelled. So it's underscore frac underscore, and we have to take that into account, so the name has to be the same. But again, it's case insensitive, so it doesn't matter if you type it with a small one or not. So n is frac minus 1. And let's see what we have. And remember that programming is an iterative process, so you actually have to run your code a few times to make sure that everything works, rather than, you know, create it once and then not be able to identify your errors. So yes, now this n is correct, and now all we have to do is just divide this by n, this by n, this by n, and so on. You know, this is all we have to do. And we are going to do it again here. So we'll need med, MSC, RMSE, and also MAPE and MPE. And let's do this. So to calculate med, we need our absolute, so abs, right, ridership divided by n. And we will go here, we have this abs sum, and that's exactly what we need. So this is the sum of the abs column, of the total column. So if you remember, we said auto name, and you can see sum, sum, sum. So all of these end with the sum. So we will start with the abs sum divided by n. Abs sum divided by n. And that's gonna give us the med value. Now let's go for the MSE. For the MSE, we needed, so you remember that this is the mean squared error. It kind of penalizes those values that go too far from the actual values. It inflates them, and it shows to you. So if you see like really huge MSE, it means that sometimes your forecast gets stuff wrong, like super wrong, you know, and that's what it means. So here we had diff squared, and that's what we are going to be using here, because that's the formula, and we will divide it by n. But we need the sum of this, right? Remember that we also need the sum. So it will be not just diff squared, but it will be diff2 underscore sum. It's here, and you can see that it's a pretty large value so far, and we'll divide it by n, and that's it. And that will give us our MSE. So diff squared underscore sum over n. That's our MSE. Our MSE is easy because we only need to take square root of MSE. That's all. Remember to put those semicolons, guys, because if you don't, then SAS cannot read the command. That thinks that the line continues, and it gets it all wrong. So now MAPE, we need to multiply it all by 100 with our percent. Or you could just actually use the format percent, so we can do it later. For now, let's just not worry about it. So we need actual minus forecast divided by actual, and that was this one, division of abs by ridership, right? So it will be div by abs, but also it will be the sum of them. Let's see. So it will be div underscore abs underscore sum. So div abs sum, and again over n. That's what we need. And the last one, MPE, this is our regular division, right? Because we have again the sum of actual minus forecast over actual, then we summarize everything and find the mean of it. And this is what we have here. Let me just expand it a little bit. Div underscore reg underscore sum. So div reg sum over n, and these will be our errors. Run selection. Okay, so let's see. And now we have these errors. So we have our MED, we have MSc, RMSc, MAPE, MPE, and we have all of that for the training set, right? And that's all we needed. And of course they are going to be the same, they're going to be replicated, which is not super productive. But my goal was just to show to you how to actually calculate it all pretty much in one set, right? Now we have this set naive FCR, and what we could have done, we could have just, you know, taken yeah, and also by the way, for MAPE and MPE, let me just finish with that one, and then I will show you what we could have done. Okay, so format, and now we need MAPE and MPE percent. It can be, I don't know, 10.2 maybe, something like that. So let's see if it's enough or not. Hopefully it will be. I mean, it should be actually 10. It should be like 2 maybe or something. Okay, so now we have this percent. You can also see that this is negative. And yes, so we have this, and let me see, 1, 2, 3, 4, 5. We have 5 plus these two 7, so we could have said maybe not 10, maybe 8, but that's fine. You know, we are working with our computer, we don't have to save any space, but in real life you really want to be careful with these, because you're occupying space, it takes time, so you know, just yeah, maybe you should be careful. So we could have we could do the same for the not naive. Now we could just copy it and do the same for the validation. So these were the train errors. Now let's do the same for naive errors. And again, guys, we need to run this proc means that will give us pretty much the same data, but for a different data set. So we also have to change some stuff, right? So we're not doing now the naive data set, but we're using the naive valid. And I really recommend that you copy them. I mean, if you don't, just make sure that you type them properly, and if you see an error, don't really freak out, because it's okay, you know, we all make mistakes. You saw me today. And naive valid, so some naive, and now instead of train we'll say VD, just small ones, and that will be validation. So that's our proc means. Let's run it. We don't want to print any data because it will be just confusing. Okay, so now we have all of this stuff. Here we actually don't have to change the frequency. We'll just have to keep it. Again, now it's not naive forecast error, but it will be naive, let's say, validation error. Okay, and the set that we are using here is naive underscore valid. Yes, and the set that we are calling to be added to that naive validation set is this one. Okay, so here we do not need to subtract 1. We only need to create a new variable. That is going to be nice because we do not have to change anything else. And now we just run this one. Okay, so that's perfect. So guys, that's all we needed, right? Yes. And that's your error calculations, but it's really not super convenient, right, to use them. You could export them, again, like I said, into CSV or Excel format. You go into export and export naive, and then create an XLSX or CSV file. You could do that. What you could also do, you could use the where statement, and you could keep some of the variables. So you could create a new set here. You could create data train let's say naive train errors, and you could call the set naive forecast error. And all you have to do pretty much is to keep some values, right? But you could also have to say where, and you need to say the condition. So the condition is that we only want to keep the first row of our value. And let me just go here, some naive train, and let me check what it was called. So the naive forecast error, right? Naive forecast error should be here. If it didn't get created, we can just click refresh. Naive forecast error. Okay, so we can see now that our date is 0.1 Gen 91, and that's what we are going to go for. We will say where date equals 01 Gen 1991 D, and we'll run. Okay, so that's exactly what we need. We do not need date, we don't need ridership because it's irrelevant. Our ridership changes on a monthly basis. We don't need frequency, but we can really need this part, right? Like the N, maybe, and all the rest of these guys. So we have a few options. Either we ask to keep these, or we could ask to drop these. I will just ask to keep these because we do not have that many of them. So that is why I would like to keep them. Oh, sorry. Would like, hopefully I will be able to copy them. Shall I just copy with headers, maybe, if it's possible? So let's see, and let's say, we could use it here. Keep equals. We don't need this part, but at least, you know, we were able to copy the values. So when you're saying keep, you just specify which variables you want to keep. You could also use a drop statement, you know, it depends on what you have more of, right? And let's rerun it. And this is what we have. So these are our errors, but we only have one row. And we will do the same. Again, I will just copy so that you to save time, not just to retype it again and again. And instead of saying naive training, I will just use naive validate, and also I will need to use the previous set naive VDR, right? Okay, and now our date is actually going to be different. So let's see, naive VDR. Our date is going to be April 2001. So again, we'll just have to change a little bit. I'll say April 2001, and naive VDR is true, and NVDR. Okay, that's perfect. And now we have these two neat sets, but we could even go further, and we could actually go to, let me just go here to process flow, wherever. Actually, we can just go to tasks right away. So we can go here, tasks, append table, because we have tables of the same width with the same information, you know, and that's why we can actually, you know, use them. So this is naive validation, and we could also add. So let me just click on add table. We'll go to work library. So local libraries, and we need a work library, and we need a naive train error. And we also need to place them in a different order. So now we have this naive train error, naive validation error. We can also go to results, and we can now create one set, right? We don't need to create much, but we can create one permanent set, and we can say BST477 naive errors, and that's it. Let's run. So you can only append tables if they have the same number of columns. Rows you don't care about, But if you have different number of columns and if they have different names, forget about appending them. Now we can actually compare the sets, right? So we have different number of ends, which is okay, but you can see that our med for the training is pretty different from our med for the validation set, which is not really a good thing to see. We can actually see all of these differences here and here, and that tells you that there is overfitting. So what it means is that actually, I mean, you don't even need to really be a genius to guess that, right? Because we took only one value from 2001, right, March 2001, and we were using that value to forecast 3 years. And definitely a lot of things were going on. We also saw that there was a trend. We also saw, you know, seasonality and other things. So definitely it's not the best forecast ever, but you know, we tried, right? And this is what we have. Now it would be maybe super smart to take this and export it into an Excel file, and also all your forecasts, you know, with all of those things. And let me just export it. Okay, just here, for example. And I will have it in my tutorials folder. I'm not gonna go there, but the point, you got it. So this is how you actually run a regular, simple, naive forecast in SAS, and how you calculate those errors. And this we don't need. And yes, that's it, right?